So for nomenclature and structure of alkanes, you should be able to go from name, such as methane, and draw either the molecular formula, the Kekulé structure, the condensed structure, or the line structure. And you should be able to build a model given a model kit. As I said, the most difficult prefixes are going to be meth, eth, prop, and bute for you, and I would begin memorizing those immediately to know that meth indicates 1 carbon, eth indicates 2 carbons, prop indicates 3 carbons, and bute indicates 4 carbons. As we get into more complex structures, the names will become longer, but there is a system to naming, and I hope that you will understand its logic. So, nomenclature of alkanes. When we have a molecule with the molecular formula C4H10, it can be arranged in 2 ways. It can be arranged as butane, or what they call as a common name isobutane, but has a systematic name, what we call the IUPAC nomenclature. So the IUPAC systematic nomenclature, this is the nomenclature system developed by the International Union for Pure and Applied Chemistry. And this nomenclature, we'll go through the rules, is going to have a, it is going to give us the structure very carefully. For example, isobutane, which is the common name, has a systematic name of 2-methylpropane. And the way that this works is that propane is the longest carbon chain, the chain containing the highest number of carbons. So we have 1, 2, 3 carbons, and that the prefix is going to indicate where there are any branches. So if we have a 3-carbon chain, then we can say that at carbon 2, we have a 1-carbon group, which would be called a methyl group. Butane and 2-methylpropane are constitutional isomers. These are isomers that have the same molecular formula, but the atoms are linked differently. Another type of stereoisomer that you may have learned about in Gen Chem are cis and trans double bond molecules. So they have the same molecular formula, but the same connectivity, then we can call it a stereoisomer. Same formula and same connectivity. These are stereoisomers, so the carbons and hydrogens are all connected in the same way. But because there is no rotation around the double bond, the structure is different and has different physical properties. The trans double bond has no dipole moment, and the cis double bond does have a dipole moment. There are distinct differences. We will cover the stereoisomers in chapter 4, so don't worry about that right now. But I do want you to remember the term constitutional isomer and the definition that a constitutional isomer has the same molecular formula, but the atoms are linked differently. They are bonded differently. For nomenclature of alkanes, if we look at a 5-carbon molecule, we can draw a 5-carbon molecule in 3 different ways. We can draw it as a straight chain with each carbon connected in series. We can draw it as having a 4-carbon chain with a 1-methyl branch. And we can draw it as a 3-carbon chain with 2 methyl branches. So the systematic name for this middle carbon would be 2-methylbutane. And the reason that I'm stressing systematic names is that common names are not asked on exams, either by the ACS or, to my knowledge, the MCAT. Now, we have a common name of neopentane that you may see on the homework or in the chapter for 2,2-dimethylpropane. And so I've written out that name for you here. Looking at further structures, hexane can be arranged in 5 ways. So it has 5 constitutional isomers. And you can see if we only used common names, then that would be a lot of different names to remember. That is why we need rules for drawing structures that help us to name something in a logical way with a set number of rules. So here are the 5 isomers, constitutional isomers of hexane. We have hexane, 2-methylpentane, 2,2-dimethylbutane, 3-methylpentane, and 2,3-dimethylbutane. For when we get up to 7 carbons, there are many, many ways to draw C7H16. And in fact, there are 75 alkanes with the molecular formula C7H16 and 4,347 alkanes with the molecular formula C15H32. So it can get really complicated drawing the different possible constitutional isomers of carbon chains. Alkyl substituents. Removing a hydrogen from an alkane results in an alkyl substituent. We will replace the ane with il and write YL. So, what do we mean by substituents? I've said in a previous chapter that this is when we have a branch off of a longer carbon chain. So here at the bottom, I have drawn a molecule that has ten carbons in the longest chain, and it has 2 substituents highlighted in yellow. One of these substituents has 2 carbons, and you're going to count those carbons by numbering the carbon closest to what we call the main chain. Let's highlight the main chain in green. So here's our main chain highlighted in green. And this, and then the substituents are highlighted in yellow. So you want to number the substituent by numbering the carbon connected to the main chain first. So I would call that carbon 1. And numbering the carbon connected to the next carbon as the next substituent in line. So if this is 1, then this is 2. And the other substituent at carbon 4 is only 1 carbon. And so as a branch or a substituent, the group at carbon 4 would be called methyl because it contains only one carbon. And we use YL when we have a short chain like that. It's a branch off of a larger number of carbon chain, and it will be a prefix. And the other thing that you will do is you will show like a map where that methyl is located by writing the number before the prefix. And so then at carbon 7, the second substituent contains 2 carbon. And so we would write 7-ethyl. So we have a 7-ethyl substituent. And these will all be incorporated into the name. And because there are 2 substituents, what is going to take priority is not the carbon number where the substituent is located. What is going to take priority is the alphabetical order. So we would say 7-ethyl 4-methyl, or in this case, I may actually change the numbering so that the substituent, which becomes alphabetically first, has the lower carbon number because I happen to draw a molecule where the numbering is the same in either direction, where we're going to have a substituent at carbon 4, carbon 7, no matter how I number it. And so I'm going to number it so that the alphabetical substituent has the lower number. But we won't always do it that way. It just turns out that way for this particular molecule. 7 and then 4. Don't try and write down all the rules just yet. We are going to go through the rules in a systematic way. I'm just trying to get you used to and expecting of what we're going to encounter. So I would name this molecule 4-ethyl 7-methyl, and notice that when I write a number, following the number is a dash. And if I have a prefix, then there must be a dash between the prefix and a second number. So numbers must always be separated from names with dashes. 7-methyl decane, and there is no space. So these are going to be really long words. So that is how we would do substituents. These are for simple straight chain substituents. I'll show you how to do some other substituent naming as we continue. But a 1-carbon substituent is methyl, then we have ethyl for 2, propyl for 3, butyl for 4, pentyl for 5, or for any straight chain alkyl group, the prefix followed by YL gives the carbon number in the substituent chain. Common names. So we have here a list of molecules, common names, and of different functional groups, alcohols, amines, and alkyl halides and ethers. The molecules shown here are common names for these molecules: methyl alcohol, ethylamine, propyl bromide, butyl chloride. We are not going to use common names, but you may need them on the homework. I think that there's at least one homework problem where I wanted you to have experience using the IUPAC name, but they also asked for the common name, and I couldn't separate the two. I couldn't separate IUPAC and common name. So you actually have to do both. There's a website that can help you with naming. I'll show you that really quickly. That is PubChem. So if you go to pubchem.ncbi.nlm.nih.gov, you will find the PubChem government site for structures, and you can draw a structure. So if on your homework you are given that they want you to draw something or name something based on a drawing, so say we want to name a 5-carbon molecule, which, or actually, how about 10-carbon molecule with 2 carbons at carbon 3 and 1 carbon at carbon 5, and they're asking you the name. You can determine the IUPAC name on your own. I hope you'll try to do that before looking up the name in this site. So we have a group at 3, carbon 2, and a group at carbon 3. But for the common name, I do recommend that you use this site. So you can do search this structure, and it will give you both the, it will give you all naming possibilities for this structure. When you click on the site, it has the common name and the synonyms. So if you go scroll down, as names and identifiers, it's got the IUPAC name. I thought I put 10 carbons. Hey, where's the other methyl group? Okay, go back. Go back. Go back. We drew like this, then this, then this. Search for this structure. Ha, there it is. All right. I don't know what happened before, but it has the IUPAC systematic name. It should also have the common name. So depositor supplied names, these are common names given by the persons selling the chemical, and we should have somewhere synonyms that will help you to determine the common name for these structures to answer your homework problems.